All right, so let's just go over one more thing. We learned what? Tell me three things, three series that we learned. What's the three series we know? Geometric, telescoping, and then what? P-series. How many tests have you learned so far? Integral test, comparison test, and then yesterday we learned what? We learned what yesterday? Alternating series test, right? This is alternating series, we can do test. So today you're gonna learn ratio test, and then you're gonna learn what? Root test. Okay, let's look at the ratio test first. Ratio test means if I give you a problem series, okay, given series as your problem, you are going to find a sub n plus 1, which means whatever you see your n, you're going to make it to be what? N plus 1. Is everybody with me? Say your series is a sub n equal to n. What a sub n plus 1 means? Equal to what then? N plus 1. Are you with me, class? That's what a sub n plus 1 means. You're replacing all the n to the what? N plus 1. So you are exactly 1 bigger than previous one. Okay. So to do this, they give you three things. What's the three things? When does converge? Whenever you have, so this is absolute value, okay? It's absolute value. A sub n plus 1 divided by a sub n is what? Less than 1. That case converges. So in other words, if this number is bigger than 1, well, 1 or bigger than what happened? Diverge. Okay, but now look at this. There's a one case. If exactly 1, you don't know what to do. That case, you have to do other tests. Are you with me, class? When you take the limit and that happen to be exactly equal to 1, it's called what? It's ambiguous. You don't know whether it converges or diverges. That case, you have to do other tests. I'll talk about that later. Okay, for now, you don't have to worry about it. So problems that you're going to have, either it's converge or diverge, but not equal to 1. All right, so now ratio test. That's what ratio test is. Okay, by the way, what's the definition of a ratio? Taylor, what's the ratio? Lakana, what's the ratio means? It's a comparing. You have a numerator and denominator. You get to what? You get to compare numerator and denominator. You get to see a what? What is their ratio, right? What is their portion? That's a ratio. So now I'm going to do what? I'm going to test the root test. What's the root mean? You're taking a root, like taking a square root, or taking a cubic root, or taking a what? Nth root. So it depends on the power. So your series has the nth power. Then you're going to take a what? Nth root. If your series have a square root, I mean, if your series has a 2 power, then what do you take? Square root, that's right. If your series has cubic root, what do? You take, I mean, if you have a cubic power, then what do? You take a what? Cubic root, that's right. So again, this is the same thing. If you take, if n goes to infinity, okay, and that is less than 1, that also what? Converges. Okay, just like the other one. So in other words, if that is bigger than 1, or goes to infinity, then diverges. Again, inconclusive when equal to 1. All right, example 1, determine the convergence or divergence of given series. So what do we do? This is what you need to do, all right, class? So this is what you need to ask yourself. Is this statement true? Limit n goes to infinity, absolute value of a sub n plus 1 divided by a sub n is less than 1. If that's true, then what can you say? The series is what? Converges. Are you with me then? I can say the given series converges, right? Now let's do that. So how I'm gonna do? First thing first, okay, create your a sub n. So I'm gonna call n, which 2 to the n divided by factorial n. Are you doing yours? Okay, do yours right now. Okay, so what's the next one you need to do? Remember, we gotta compare. So we need to define which one? Second series, right? A, right. So I'm gonna call AN2. All right, did you see that I replaced N with what? N plus 1. So I put the 2 to the N plus 1 and factorial then what? N plus 1. Is everybody with me? Let's get run that. Okay, now since it's a factorial, and remember yesterday we saw it, factorial, like after 5 factorials, you get A sub N plus 1 and A sub N, but they're about the same. So I decided to just stop at 7. You don't want to use 100. What happened? It's not textbook. It's like you cannot do it. It's overflow. It's like my computer cannot handle this. The Julia cannot handle this. So, okay, so I'm only gonna do 1 through 7. Okay, let's look at the numerically. What happened with my sequence? Because remember, you want your sequence to be what? Each term gets smaller. If that's smaller, then I know it converges. So I'm gonna look at numerically. I'm looking at the first 7 elements, starting with the 2, 1.33, 0.66, 0.266. So what happened? It's a good sign, right? It's getting smaller, but I like to see that. Okay, let's look at the next one. All right, there they are. And let's plot those. All right. Okay, which one is which? The blue dot is A sub N, and the red dot is A sub N plus 1. So which series is bigger, A sub N plus 1 or A sub N? Look at the dot and tell me, look at the graph and tell me which one is bigger, which one is a larger series, A sub N or A sub N plus 1? A sub N, because look at, let's look at the one number, let's look at the 3. Okay, 3, what's Y value here? It's like 1.4. What's Y value for the blue one? 2. So which one is bigger? Blue dots, isn't it? How do you compare? You look at the exact X and look at the Y values of each. You see, as you can see, this is just smaller than what? That one. Are you following me? Okay, you need to know how to see your graph. That's like a skill. Anybody who do analytics things, you will look at the graph and you're supposed to kind of see the big picture. Do you see a big picture? Okay. So that's why I graph all the time, because you know, all right, so that's a good thing. That's definitely a good thing, because you want, remember, think about the, not yesterday, but was it, when did I teach you guys about, it was yesterday, yeah. The alternating interval test. What did you test? What do you want? What's the second condition? A sub N plus 1 is less than what? N. So that condition is usually true for every series. You want to have that conditions. All right, so now I'm gonna find the ratio. The ratio, did you see that I put the dots, right? Why am I putting these dots? Because I want to do a evaluate each X, okay, each element. So you got to put the dot, so it's mapping. So I'm broadcasting, so do that. Let's look at the ratio. All right, what does the ratio shows? All right, very first one says 1. It's no good, but we don't care about the when N equals 1. We want what? N equals what? N goes to infinity. I want the ratio to be less than what? 1. So what happened here? Do you clearly see the ratio is getting smaller? Yes? Yes or no?
Yes, it goes from 1 to 2/3 to
okay.
To 4%.
You need to literally see this numerically, okay? And then let's graph this. Can I see that in graphically? Numerically, I saw that. Now graphically, look at that. See the very last one? When 7, element number 7, the term number 7, the Y value is what? 0.25. Yes, it's getting smaller. But if you want to do more, yes, you can do more. Like, I can go all the way to what, 10 terms if you want to. All right. Anybody have any questions? So what can you say now? Looking at this numerically and graphically, what can you say about this given series. It converges. Why? Because it's what? Less than 1. So example 3, we're gonna do, okay, now look at this problem, the given problem. Okay, for this problem, why do you want to use the root test? Look at the power. This is a good example. Look at the power. What's the power? Your numerator has n power, denominator has what? M power. So in fact, I can rewrite it. So I'm going to do e to the n over n, and I can rewrite like this. Does everybody see it? When you have problems like that, you need to put the common power as a numerator and common power as denominator, put them out of what? Make the common factor. Okay, then when you see like that, then you're gonna tell yourself, oh, I need to use the root test because I can put over what? I can just put the nth root over this. Is everybody with me? Okay, why are you using a root test? Because you have a numerator and denominator has the same power. You can factor them out and put outside of what? Parentheses, and you can take the root of them. Is everybody with me? Okay, so we're gonna ask same question. Is this statement true as what? When you take a nth root and take a limit of that goes to what? Less than 1. Okay. Let's make sure that's less than 1. Then it converges. Otherwise, what? It diverges. Okay, so let's apply. Hey, did you see that? I'm using an m because I don't want to use n anymore. I use n for example 1 and 2. So I'm going to use m. Does it matter what letter I use as my domain? No. Okay, so I'm just doing that. So this one, I'm going to use m to be 1 to 15. Run your code. Let's just see numerically. How does it behave? This behaves kind of weird, isn't it? 7, look at this number. 7, 13, 14, 11, 7, and 1, and then what? Come back to 2.
This is 0.
Oh, so it's getting smaller. Good. It's definitely getting smaller. That's a good news. So let's go ahead and graph this. Oh yeah, definitely it's getting smaller. It's a 0. That's a good news, right? Let's look at the root test. So I'm going to say C and root test, absolute value of C sub n. Hey, make sure you put all the parentheses in the right place. Remember, cover the n, cover the C, cover the absolute value. Okay, you need to make sure your parentheses align, otherwise it's not going to work. All right, now let's look at the behavior of the root. They are also getting smaller. Good. Now let's look at the scatter of that. All right, that's good. 0.49, and it's what? It's gradually getting smaller. So what can you say? What can you say? Does it converge? Yes. Why? When I take the nth root of the given series, what happens? It's less than 1 as n gets what? As n gets what? Larger.